Good morning, Algebra 1. Today, we're going to kind of continue with what we did yesterday where we talked about functions and relationships, and we're going to add in domain and range. So just a little thing to recall from yesterday. A relation is a function if and only if every input has only one output. So when we talk about domain and range, if you remember, domain is all of our x values. So all of our x values in that function. Remember, our x values are also our inputs. Our range is all of our y values in the function. And those are also known as our outputs. So remember, inputs correspond to x, outputs correspond to y. So there is a way that we kind of remember all this. We have this little acronym we use. And that is Dix-Roy, where D stands for domain, I stands for inputs, and X stands for x coordinates. So our domain, input, and x coordinates all go together. Those are all referring to the same thing. And then we have these, kind of highlight this, outputs or range, which coordinates with our outputs and corresponds to our y coordinates of our points or our function. So what we're going to do today is practice writing the domain and range of some of these functions. So to write domain and range is pretty simple. Anytime you're given a graph, I'm going to label these points. So these are the points 1, 5. This one looks like it's at 3, 5. Then we have one at 4, 2, and one at 6, negative 2. Okay, so our domain is all of our x values. So our domain is just going to be all these values of x. We do list them from smallest to largest. So our domain, we use these little funny bracket things, is going to be 1, 3, 4, and 6. And our range is all of our y values. Again, we're going to list them from smallest to largest. And if we have the same number listed twice, we only have to list it once. So we have negative 2 as our smallest, then 2, and we have 2 5s, but we only need to list one of them. Now this function that is just a bunch of points, this graph, we call this a discrete function. This is what we're going to be looking at. I am going to show you what a continuous function looks like, but you don't have to worry about continuous functions for a very long time. So looking at a continuous function, if you can see, if you want to add arrows, that might make it make a little bit more sense. When we look at our continuous functions, they don't have a bunch of points. So what that means is this graph is going on forever. So when we talk about our domain, our x values go from left to right. So when we're looking at our x values for a continuous function, we're looking to see, as this graph expands, is it going to keep going to the left? And the answer is yes. As it expands, it's also going to keep going to the right. And we denote these with infinity symbols. So if it's going to keep going to the left, we say it's going to go to negative infinity. If it's going to keep going to the right, we say it goes to positive infinity. Because on the left side, our x values are negative, and on the right side, our x values are positive. But they're going to go on forever and ever and include every value of x. Our range, remember, talks about our y coordinates, so our y-axis runs up and down. And this graph goes from a y value of 2 all the way up. It's just going to keep going up forever. So to write that range, we would say it goes from that value of 2, and since it's going up, it goes towards positive infinity. And this is considered a continuous function. Now, you don't need to know how to do that. If that was confusing, don't worry about number 2. You just need to know how to do number 1. But I did want to show you the difference between discrete and continuous. So discrete are distinct values that are not connected, or points that are not connected. So a graph like this actually has a name. We usually call it a scatter plot. Versus a continuous function is made up of lines or curves as graphs. So meaning we have these lines that are going to go on forever in some directions, not just a bunch of points making up the graph, which is called a scatter plot. When you are ready, you can flip to the back side. Okay. So what we are doing next is we are determining if the function is a relation, and if it is, we are going to identify the domain and range. I'm actually going to have us identify the domain and range for all of them just so we can get some practice. So looking here at our mapping diagram, we need to determine, is this relation a function? And remember, we're looking at these x values. Do they go to more than one y value? It looks like 1 only goes to one value, 2, 3, and 5. Each only go to one output, so this is a function. And remember, to write our domain, we're just listing all of our x values from smallest to largest. So we have x values of 1, 2, 3, and 5. And then we're going to list our y values, which make up our range. So since our range is our y values, that's going to be 4, 6, 7, and 10. All right, same idea for the next one. We're looking to see, is this a function? And unfortunately, this is not, because 2 is going to 4 different outputs. It can only go to one output. So no, this is not a function. Although I'm still going to write the domain and range just for the practice. So remember, our domain is all of our x values. We only have one x value here, or one input. So that would just be 2. And range is all of our outputs, or all of our y values. So that would be 4, 6, 8, and 9. All right, let's take a look at these next ones. Now we have a set of points, or ordered pairs as we call them. And again, we're looking to see, are these functions? So looking at our first one, let's look at all these x values. Oops, I was using blue for x. Okay, we have 3.1, -3, -3.2, and 3.1. Well, looking here, we have these x values that are the same, and they have different outputs, which means this is not a function. But again, we're going to just practice writing this. So we're going to start with our smallest x value, or input, and that would be -3.2. Then we have -3.0. And if you have a number listed more than once, you only have to write it one time. So 3.1. And then we'll take a look at our outputs. And I'm again going to list these from smallest to largest. So it looks like my smallest number is -2.7, then 7, 9, and 18. All right, I'm going to let you try the next one. I'm going to give you about 1 minute, see if you can decide, is it a function, and write that domain and range. All right, let's take a look at this one. So, is this a function? Let's look at our x values. So we have 5, 6, 5, and 2. We do have 2 5s here, but they have the same output. They both have 4 as an output, which means it's the same point. So this is a function. This is that one exception. If we have the same x value listed, but it has the same y values, it is a function. So our domain from smallest to largest would be 2, 5, 6. And our range would be -8, 4, 7. All right, that is it for the notes. You may use the rest of this time to work on your homework. I will be checking in the homework from yesterday and today's homework on Monday.